Hi everyone. So now that we know how to graph systems of equations where both equations are in slope-intercept form, we're going to be taking a look at systems of equations where one equation is in the slope-intercept form and one is in standard form. Standard form is when we have that ax plus by equals c. So let's take a look. Okay, so solve the following systems of equations graphically on the set of axes below. So here we have y equals negative x minus 8 and 5x minus 2y equals 2. So here we can see that this is in slope-intercept form and this is in standard form. So the first thing that we want to do is make sure that both of these equations are in y equals mx plus b form. So this one is, but this one isn't. So let's tackle that first before we start graphing. So hopefully remember that the first step is to move whatever term has that x value. So because this is a positive 5x, I'm going to go ahead and subtract 5x from both sides. You can draw your train tracks here if you need to, but just for space, I'm not going to. That cancels. We get negative 2y is equal to, and remember, these aren't like terms, so we're going to take that and put it right in front. So I'm actually going to write that in red. So negative 5x, and that's a positive 2, so that becomes a plus 2. Do not combine those. They are not like terms. Okay, now let's divide everything by what's in front of y to get y by itself. Remember, we want to solve for y, so we want to isolate. That cancels here, so we're left with y equals. Now we have negative 5 divided by negative 2. A negative divided by negative gives us a positive, but we're not able to simplify that fraction, so we're just going to leave it as a positive 5 over 2x, and then 2 divided by negative 2 gives us negative 1. Okay, so now both of these equations are in slope-intercept form. Let's go to the next step. Okay, let's graph the first equation using the slope and y-intercept, and then we're going to graph the second one with that same method. Okay, so I'm going to do this line in red. So our slope here, remember if there's no number in front, there's an invisible 1. So we write that as negative 1. Let's write that as a fraction. Just put it over 1. And that's telling us that we're going to be going down 1 to the right 1. And then our y-intercept here is negative 8. Okay, so we're going to start at our y-intercept, negative 8. And we're going to go down 1 to the right 1. So down 1 to the right, down 1 to the right. Now that's only 3 points, so I'm going to go in the opposite direction because I want to have as many points as possible. So now I'm just doing the reverse. Up 1 to the left 1. Point, 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 point. Okay. Now I'm going to connect these points to the best of my ability. Okay. Now we're going to graph this second line here. I don't have too much room to write what m and b is, so I'm going to just eyeball it from the equation. So here I know my y-intercept is negative 1. I'm going to put a point where y is negative 1, and then our slope is 5 over 2, so that means we're going to go up 5 to the right 2. So up 1, 2, 3, 4, 5 to the right 2. 1, 2, 3, 4, 5 to the right 2. And I'm going to do the reverse. So I'm going to go down 5 to the left 2. So 1, 2, 3, 4, 5 to the left 1, 2. And then 1, 2, 3, 4. I can't go any further, so I'm going to stop there. And I'm going to connect these points. And we can see that these lines intersect at this point here, which is the point negative 2, negative 6. Negative 2, negative 6. I'm going to write up here, negative 2, negative 6. That is the solution to this system of equations. Okay, let's take a look at one more example. All right, so we want to solve this system. This is in slope-intercept form. This is not. We have y equals negative 1/2 x minus 5, and then x minus y equals 8. So let's handle this first. Let's get this in y equals mx plus b form. Okay, Okay, so first things first, move your x value over using inverse operations. That cancels. So now pay very close attention. This is a minus y, so we're going to bring it down as if it's a negative y. Don't leave that negative there. These are not like terms, so I'm going to take that term and put it right in front of the 8. So you get negative x plus 8 because it's a positive 8. And then y is still not by itself because we have this negative 1 in front, so we're going to divide everything by negative 1. So here we're going to get y equals, now negative 1, because there's negative 1 there also. Negative 1 divided by negative 1 is a positive 1. So positive 1x. And then 8 divided by negative 1 is negative 8. Okay, if we want to just put it in a bubble, what our slope and our y-intercept for this would be, our slope is 1, so that's really 1 over 1. And then our y-intercept is negative 8. All right, for this first equation, we don't need to do any of that because it's already in slope-intercept form. So we know that our slope is negative 1/2, and our y-intercept is negative 5. So let's start graphing this first equation. I'm going to do this in green. The y-intercept is negative 5, so I'm going to put a point at negative 5. And then our slope is negative 1 over 2, so that means we're going to go down 1 to the right 2. Down 1 to the right 2, down 1 to the right 2. Repeatedly, do it on the opposite side, so you have as many points as you need to when you're doing this by hand and on paper. Okay, let's connect these. Okay, and then I'm going to graph this second line here. Our y-intercept is negative 8, so let's put a point at negative 8. And then our slope is positive 1 over 1, so we're going to go up 1 over 1. Up 1 to the right 1, to be more specific. Repeatedly, repeatedly. Remember, they have a constant slope, constant rate of change. So the slope needs to stay the same throughout this whole line. So now I'm going to, that's a little off, but it does the job. Okay. And the point where they intersect is this point right here, which is the point 2, negative 6. I'm going to write that up here. 2, negative 6. Okay, so make sure both lines are in y-intercept form. You're going to have to use inverse operations if they're not, just like we did down here. Once they're both in that form, graph one line at a time and then circle wherever they are going to intersect. And this arrow, for some reason, did not stay, so I'm going to make sure. Make sure you have arrows on both ends, though. Okay, good luck.